Good afternoon and welcome to the second session. This session is going to be a little different than the previous month session because this is all of the elementary grade levels, which is 3rd, 4th, and 5th grade. So we will be reviewing assessment items from the 3rd, 4th, and 5th grade during this session. Once again, this is providing an overview, or not necessarily an overview, just sample of assessment items from resources or that we have been provided by the Georgia DOE. So once again, I am Sawanda Coffey. I am the math mentor here at West Georgia RESA. What I would like to start off by saying before we get started is last month when we talked about the different grade levels and the assessment items, gave you an idea of how the questions may be mimicked or modeled after as a prototype. And last month's resource was Engage New York. Okay, to continue on with our norms, of course, they are the same as always. You will be muted during the presentation, and that is, of course, to just reduce the amount of feedback that we may experience in our different locations. Also, you may type in questions during the presentation if you would like. If I'm not able to answer any of your questions during this session, then of course I'll consolidate those and provide answers to you via email. Also, at the end of each of the presentations, there will be a link to the recording uploaded to the West Georgia RESA site. Now, in order to go back and access the webinars, you would visit the West Georgia RESA site. There is a Services tab located at the top left. You would click on that tab, and you will go down to where it says Recorded Webinars. Okay, we're going to start off, of course, with 3rd grade and the 3rd grade standard and the lesson essential question. The standard for today is MD.7A, and that standard says, find the area of a rectangle with whole number side lengths by tiling it and showing that the area is the same as would be found by multiplying the side lengths. The essential question for this particular standard is, how do we find the area of a rectangle with whole number side lengths by tiling it? Of course, if you joined me last month, how I try to format the webinars is I want to, of course, provide the assessment item itself, but of course the standard and the lesson essential question, but I also want to integrate the standards for mathematical practice. So the standards of mathematical practice that relate to this assessment item that we're going to review for 3rd grade is standard number 1, and that's make sense of problems and persevere in solving them. I will say again, standard number 1 is one of those standards that we should be demonstrating as teachers in our classes every single lesson. Now, standard number 2 is reason abstractly and quantitatively. Standard 3 is construct viable arguments and critique the reasoning of others. In the assessment item, we'll be more concentrated on, of course, the construct viable arguments. But since these are sample items that you could use in your class, then it would be appropriate if you would allow the students to critique the reasoning of others. Standard 4 is model with mathematics. And then standard 6 is attend to precision. As I stated with standard 1, standard 6 is another one of those standards that we should demonstrate as teachers in every lesson that we provide to our students. Okay, the assessment item for 3rd grade, it is a constructed or maybe an extended response assessment item. We'll see when we actually get to the student work. But this constructed response assessment item, it states that Jaya drew a shaded rectangle on a grid as shown below. And it also gives you a key that says pretty much one block stands for 1 square unit. And the resource that I am highlighting this month is from Massachusetts. It's Simple Items, and I will provide the website for you at the end, so you'll be able to once again add this to the resource from last month and be able to explore throughout this month. All right, the question, or the first item, which is item A, it says, what is the area in square units of J's shaded rectangle? It says blank. You show or explain how you got your answer. So we're going to be looking at that. And then part B, it says Mark also drew a rectangle. Mark's rectangle has the same area as J's rectangle. Mark's rectangle has a width of 3 units. What is the length in units of Mark's rectangle? And then they wanted the student to pretty much draw Mark's rectangle. Take just a couple of seconds just to look back through that just to understand, so when we get to looking at some of the student work, then we're very familiar. Now also, as a general format that I am providing is, of course, some strategies to address the problem. I have chosen the problem-solving framework from Robert Kaplinski. I've adapted it from Robert Kaplinski. And as I stated before in the previous month's webinars, I think this problem-solving framework, it works in all aspects of our classes. So therefore, I am still continuing to use it. Of course, it is not something that has been recommended through the state, but it is something that is useful. Now, the 3X tasks, those things that are embedded inside of the framework. Now, Robert Kaplinski is a creator of those, so that's why I think it's a very reputable tool to use is this problem-solving framework. So, of course, in the problem-solving framework, the first thing we want to ask our students is, what are you trying to explain or prove? And we know that in some point in this assessment item, we have to do some explanation and maybe even do some proving. Next is, what guesses do you have? We want the students to, before they actually get into doing their work or figuring out a method or some strategies that they could use to answer the question, we just want them to just take a little time to just guess what the answer may be. And the objective is we want them to, just start off with everyone in the class just being able to have that risk-free environment where all students feel safe and they can all, contribute to the lesson at this time. What do you already know from the problem? This is specific information that has been provided to the students in the problem. So we want them to be able to, recall that information or go back to the question and pick those things out, see what they need and see what things are not relevant to them finding the answer. Next is, what do you need to know to solve the problem? Once again, this incorporates some of those standards for mathematical practice. Is we want the students to be able to tell you or just tell themselves or tell another person what it is that they need to help them solve the problem. It could just be some tools, and those tools could be graph paper, it could be a calculator, but whatever they know that they need to help them solve that problem gives the teacher an idea that they have an idea of what they are trying to figure out. The next question is, what should we title this problem or lesson? Once again, after we went through the previous questions, at this point we are pretty much asking the students just come up with a title, which it may reflect back to the question that they are looking at, but it kind of brings the focus back to what they are trying to complete. Provide all of your work while working on a problem. Now, this is one where either provide the student a space on their a work section that they could provide all of their work on. The actual problem-solving framework that was provided to us when we went to the Robert Kaplinski meeting a few months ago, then it does provide an entire sheet of paper where the students are able to just work. There's nothing else that on this particular side of the framework model but a work session. And what is your conclusion, and how did you reach that conclusion? Once again, I always talk about this last bulleted item being another section that is part of the framework where the students actually are completing their conclusion in complete sentences. We have attended numerous sessions that Melissa Fincher has completed, which is the the Deputy Superintendent for Assessment. So what she's been providing to us is that we want to pretty much build our students up to where they are able to come up with the process of solving the problem, and then being able to take those processes and write that in complete sentences and then move on to solving. The constructed and extended item responses that are going to be on the Georgia Milestones is going to be more geared towards the process that the students took to actually answer the question. And so it won't just be solely on the answer that they come up with. Okay, so let's look at some student work. So this is a constructed response. As I stated, I wasn't sure from the beginning if this was an extended response or just a constructed response. And since I know it's constructed response, just by it is graded off of a 2-point rubric. I don't necessarily have a rubric to put in front of you from this assessment from this highlighted resource, but I could still use the same a rubric that I presented in last month's webinar, or you can actually build the rubric with your students before you actually provide the assessment items to them. And that is a good practice, so the students will be very aware of what you are expecting as far as exemplary answers. Let me go back for just a second. Let's talk about, this is part A of the question about Jaya drew a shaded rectangle on the grid, and we know that each one of the blocks was 1 square unit. So once again, A was what is the area in square units of Jaya's shaded rectangle, and show or explain how you got your answers. So if we notice that this particular student went back and pretty much provided the missing pieces to the diagram. And so they came up with 24 square units, and their explanation, if we notice that, is I drew in the squares in the shaded rectangle, then I counted up the squares and got 24. So once again, for our students that are going to be taking the Georgia Milestones, correct grammar on the math is not going to be of the most important if the actual person or evaluator is able to understand what they did. So, of course, in this case, I'm specifically talking about Lizanne, so that was okay. So now let's look at part B of the 2-point. Since Mark also drew a rectangle, Mark's rectangle has the same area as Jaya's rectangle. Mark's rectangle has a width of 3 units. So what is the length in units of Mark's rectangle? And the answer that this student provided was 8, because on the previous answer, the area was 24 square units. And so what this student actually did is they shaded in the width of 3, and then so of course they had to come up with a total of 24 square units. And so that would be 8 in your length. Another student that scored a 2, once again, they pretty much actually divided up their diagram as well and indicated that you had 6 times 4, because you had a width of 4 and then a length of 6 to get 24. And their explanation was area is the blocks or square units of a figure. I got the answer by counting the square units, and I also did multiplication. So they did two things. They actually just counted up the squares, but then they also did the multiplication because that's how you find the area with 6 times 4. So we're looking at different methods that student did to come up with the same answer. And once again, that's another one of those mathematical practices that if the students are able to persevere in solving, but they have that opportunity to approach the problem in different ways, and that's fine. With part B with the same student, also they did the 3 with the width across the top and then the 8 along the side for their length. So of course they came out with 8 as well, or 24 as the area when the width is 3. A student that scored 1 out of the 2 points for this particular one, we see that they also wanted to input the missing square unit block, and they did that. So of course answer A for the area, they came up with 24 as well. Okay, so let's look at B. The student came up with 12, and they have 3 with the width, but then they only did 4. So of course they did not get the full credit for the problem because part B was not correct. Because I think they missed the statement where it says Mark's rectangle has the same area as Jared's rectangle. And so they did 3 times 4 instead of 3 times 8. This student scored a 0 points out of 2. And remember that if you joined us last month, a 0 score pretty much means that the student did not have a clear understanding of what the problem was asking them to do. So therefore, they were not able to provide a logical answer for the evaluator. So for what is the area for this, they came up with 37. Did not necessarily give an explanation that would be understood of why they or how they came up with 37. Now, you do notice that they did try to fill in the missing blocks, but was not quite successful in doing that in an orderly fashion. Okay. The next is the 4th grade standard and the lesson essential question. And we see that this is NF1, and we want to explain why a fraction, A over B, is equivalent to a fraction, N times A over N times B, by using visual fraction models with attention to how the number and size of the parts differ even though 2 fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. Now, of course, this is a lot that is stated in the standard, but basically we want to explain why a fraction is equivalent to another fraction. How do we use visual fraction models to recognize and generate equivalent fractions? Of course, the standards for mathematical practice that are related to the assessment item for this 4th grade is the standard number 1, make sense of problems and persevere in solving them. Standard 2, which is reason abstractly and quantitatively. Standard 3, construct viable arguments and critique the reasoning of others. Standard 4, model with mathematics, because of course we're going to specifically be using visual models. And Standard 6, which is attention precision. Once again, Standard 1 and 6 should be demonstrated at all times. Right, the 4th grade assessment, the 4th grade constructed response assessment item is check shaded part of the 2 large rectangles shown below. Okay, we also have a key, so we know that the whole entire one represents 1. So this item has 3 parts to it. Part A, it says write a fraction that represents the shaded part of the two large rectangles. Part B says write a different number that is equivalent to the fraction you wrote in Part A. Show or explain how you got your answer. And then item C, or Part C, says in your student answer book, draw and shade a picture of rectangles that represents the number 2 1/3. Show or explain how you got your answer. So you're seeing that these items are, we're asking the students to, show and explain. So this should definitely be some strategies that we use in our classes every day to build our students up to be comfortable with answering these types of questions. Strategies to address the problem, once again, from that framework. And you are able to use whatever problem-solving framework that has been effective in your classes, not necessarily this one. And like I keep saying, it is one that I felt that you can use in all aspects of your class, which it could be whole group, small group, individual, on just skill work, and also those problem-based assignments or these constructive response assessment items. So, of course, what are you trying to explain or prove? What do you already know from the problem? What do you need to know to solve the problem? I cannot overly say this one about what do you need to know to solve the problem. If one of your students can tell you exactly what they need, then we know that they are grasping what it is that the question is asking for, or asking them to do. Provide all of your work while working on the problem. Of course, provide some space for the student to provide all of their work. And of course, lastly, what is your conclusion and how did you reach that conclusion? This should always be a written statement by the student in complete sentences. All right, this is a 4-point or scored off a 4-point rubric, so this would be considered an extended response item assessment, not necessarily constructive response, because it's a little bit more lengthier. So we're looking at Part A, where the student, it asks the student to represent the shaded blocks into actual fractions. And so the student came up with 1 because the actual key told us that the 1, even though it had 4 blocks, but all 4 blocks was equal to 1. And so the student came up with 1, and then we know that 2 on the other rectangle was shaded, so they come up with 1/2. So 1.5 represents the shaded part of the 2 large rectangles. On Part B, the student had to write a fraction that was equivalent to the fraction from Part A. And so the student pretty much gave a little work on the side where 1 is equal to 2/2. And then 1/2 plus 2/2 is 3/2. And their explanation, which is in essence 3/2, is equivalent to 1.5. And they, the explanation they gave is, I know that 1 is equivalent to 2/2, so I changed 1 to 2/2. Then I added 1/2 to 2/2 and got 3/2. You see why that? And then Part C for this student also, they had to create their own visual model. And so they came up with what you see here, and it says the 2 completely shaded, they had to come up with a visual model to represent 2 1/3. So they came up with the model that you see, and their explanation is the 2 completely shaded rectangles makes the 2 and the rectangle that is 1/3 shaded, and then the 2 and the 1/3 shaded makes the 1/3. If you add them together, then you get 2 1/3. So they created the 2 bigger rectangles to represent 1 each, and then they created a third one and had 1/3 of that shaded. All right, a score point of 3. This student, on the first one, they came up with 2 2/4 because the original, you had the 1 shaded and then 2 pieces out of 4. And what they did not do was just, of course, on part A, is just reduce the 2/4 to 1, to 1/2. On part B, the same thing. They have 1 2/4 equal to 1 1/2. Equivalent fraction is 1 1/2. Now remember that this was a 4-point rubric that they were scored off of, and their students scored 3. They were supposed to create another equivalent fraction for part B, and this student just took the part A answer and simplified it. And then on part C, they did represent 2 1/3 by their own visual model. Okay, for 2 points for this particular student. On part A, their explanation is the 2 large rectangles equals 1 1/2 because 4/4 is 1, and if only 2 are shaded, then it has to be 1/2. So from their original model, that is what they were able to explain their reasoning behind coming up with 1 1/2. On part B, it could be 1 3/6 because 1/2 is equivalent to 1/2, and I can't change the whole, or else it would be a different fraction. Once again, there was just 2 points out of 4, so not a very deep explanation of what happened or how they came, or what they were trying to explain. And then, of course, part C, they wanted to provide a visual model of 2 1/3, and this, what they have here, is their model for that. And once again, if you're noticing that students are coming up with different ways to approach the problem. This student scored 1 point out of 4. On part A, they have 1 2/4. Okay, and then you have on part B, they have 2 1/4. They do not have any type of explanation of how they came up with that answer. Even on part A, they did not provide an explanation of how they came up with their answer. And then on part C, they only have the visual model broken up into 3 sections, and only 2 parts of those 3 sections are shaded, which is not representing 2 1/3. It's just representing 2/3. And so the student must have misunderstood, instead of 2 1/3, understanding it to be 2/3. Then lastly, a student scored 0 is, once again, the student did not have a clear understanding of what was being asked in the question in any part. Part A, they have an answer, but they did not provide an explanation of how they came to that answer. Same thing for part B, and then their incorrect answers as well. So this would be an opportunity as a teacher to, just think about what is it that I can implement in my class to help this student to understand what the question was asked. Okay, lastly is our 5th grade standard and lesson essential questions. The standard is MBT.7. It says add, subtract, multiply, and divide decimals to hundreds using concrete models or drawings and strategies based on place value, properties of operations, and or the relationship between addition and subtraction. Relate the strategy to a written method and explain the reasoning used. A lot of words, very wordy. I tried to highlight the pieces of the standard that is actually referenced in the assessment item that we're going to be looking at. And the lesson essential question is, how do we use a written method to add, subtract, multiply, and divide decimals? Of course, your standards for mathematical practice related to this assessment item is Standard 1, make sense of problems and persevere in solving those. Standard 2, reason abstractly and quantitatively. And of course, Standard 4, which is model with mathematics. We always want the students to be able to model what they're doing if possible. And Standard 6 is attend to precision. The 5th grade assessment item, once again, this would be considered a extended response instead of just a constructive response. Nora is riding her bicycle on a trail that is 18.5 miles long. She has already ridden 7.36 miles of the trail. Write an equation that can be used to find M, the number of miles Nora has left to complete on the trail. Use your equation from part A to find the total number of miles Nora has left to complete on the trail and show your work. Nora wants to ride half the number of miles she has left and then take a break. How many more miles will Nora ride before she takes a break? Show or explain how you got your answer. Very good question, but a lot of things for the students to think about. So once again, you could approach it. You could give certain students the entire question at one time, or you can, break it up where maybe you do one part on one day and do the next part on another day and the third part on a third day. Some strategies to address the problem. Once again, that Robert Kaplancy problem-solving framework. What are you trying to explain or prove? What do you already know from the problem? How do you need to know, or what do you need to know to solve the problem? Provide all of your work while working on the problem. And of course, wanting those students to provide their conclusion and how they reach that conclusion using those complete sentences. Right, the first student work that was scored on 4 points out of 4 points. On part A, the explanation that the student provided and the work, it says an equation that can be used to find M, the number of miles Nora has left to complete the trail, could be 18.5 minus 7.36 equals M. Okay? On part B, the total number of miles Nora has left to complete on the trail is 11.14 miles to go. And the student provide that information to you at the bottom. The 18.50 minus 7.36 left you with 11.14. And then on part C, it says Nora will ride 5.57 more miles before she will take a break. I got this by dividing 11.14 by 2 and got 5.57. Because remember, Nora wanted to ride halfway from what she had left over before she takes another break. Another student that scored 4 points that did not have as much work provided, but they still were able to come up with the answer is part A, same thing as 18.5 minus 7.36 to find the number of miles that were left. They came up with 11.14 with their work shown of how they came up with those remaining miles. And then part C was 5.57 miles by doing the same thing as the previous student. So she had 5.57 miles before she takes a break. So once again, a student can still score 4 points out of 4 points without having, as not the lengthy explanation, but as long as the evaluator is able to understand the process that the student went through to answer. The next student, which is student number 3 that scored 3 points out of 4, they have the 18.50 minus 7.36 as a way to represent what is left over. And they went on to find the answer as 11.14 in part B as well. And then on part C, they said she has 5.57 miles before she takes a break. And my explanation for why this student may not have received the 4-point value is, of course, there was no deep explanation of how they came to the answer on part A and part B. Okay, student number 4, 2 points. Part A was 18.5 minus 7.36, what we've seen thus far from each one of the students. Nora has 11.26 miles left to go. I know this because I did 18.5 minus 7.36. And there must have been, on part C, Nora has to go 5.63 more miles because when you want to know half of something, you divide that number by 2, and that is what I did to get 5.63. So there may be some simple calculations that the student missed. The reason why they were not able to get the full correct answers. They provided some explanations, but just some minor calculations. And then the student scored 1 point. They have 7.36 plus M is equal to 18.5. This is a different approach than what we've seen before. They were not able to answer part B or part C, but they did score 1 point out of 4 just for having some type of answer that the evaluator was able to understand in part A. And then lastly, for the 5th grade student work, this student scored 0 points. Nora was 11.21 miles left. 36 minus 5 is 21. Not quite sure where they got that. They did not provide an explanation for that. Nora has 11.21 miles to complete the trail, and Nora will ride 2.3 miles. Once again, we'll talk about those students that scored 0 points. It's not very clear of what their thought process was in providing those answers. Of course, I always talk about feedback. When we are working with students and, trying to demonstrate what we want from them, one is to model, but also when they are allowed to work either individually or in small groups, we want to provide them with that feedback, whether it's written or verbal feedback, but it should be given quite frequently. The students should receive some type of written feedback at least every other week, if possible. Another with the feedback is it must be provided to tell the student their next steps and moving towards mastering the standards. What is it that they need to do next? Even the students that have mastered, what is their next step in the process of learning the standards or moving on to the next standard? And of course, I always advise use the language of the standards when providing that feedback. Go back to the standard itself, look at what it is saying, and make sure that the assessment item aligns to that so you can provide that written feedback using the language of the standards. And lastly, with our references, our highlighted reference for this month was Massachusetts Comprehensive Assessment System, and I provided the website for you. Take time out this month to review the assessment item. Also, the Georgia Frameworks has the 3-act task, all the tasks that we need to implement in our classes. We can use those to pretty much follow the model of all the problem solving questions that I provided to you or whatever you're using in your classes. If we don't have any more questions, I really do appreciate your time. I thank you again and have a magnificent Monday.